Hey, what's up everybody? So I'm going to be doing a quick demo of Kubicorn with the cluster API for SIG cluster lifecycle, the cluster API folks. I gave a demo from Denver either last week or the week before, and we lost the recording due to some video technical difficulties doing it live. So I'm redoing this video to kind of give a quick and dirty demo of the user experience of deploying a cluster API controller with Kubicorn from the ground up. So to get started, let's take a look at our cloud here. So we're going to use instances as sort of like our way of measuring what we've done in the Amazon portal here. Right now, Kubicorn only has an Amazon controller, although all you do is you define just a Docker container image to deploy as a controller. It runs as a deployment in Kubernetes. So we could actually get this up and running in GCP with the work the folks at Google have done for the, or GKE, sorry, for the GKE controller they have in open source. Anyway, here's one for Amazon. So the first thing we want to do is we want to create a concept of a cluster. So we're going to nuke our state store because we know we have nothing running, so we want to go ahead and delete the underbar state directory. The next thing we're going to do is we are going to compile a fresh copy of the Kubicorn binary from master, so we can do git status. Ooh, we're not even in the right repo. Let's do go source github.com Kubicorn git status. Okay, I've tweaked a few things. And we can just reset hard. We want to reset hard to origin master. Now let's do a git status. Remove this machine that we're going to actually recreate that file later. And one more git status for good measure. Good, we're up to date with origin master. So now we can make all and drop off a new Kubicorn binary in our path. So we can run Kubicorn and poof, our freshly compiled binary. Anyway, the first thing we want to do is Kubicorn create. We'll do the name of the cluster, which we're going to call rad demo. I use that name a lot. And we're going to say profile is equal to CAWS. And before we run this command, I want to show folks you can actually go and see the different profiles you can fix. How you do that, you should do Kubicorn create -h for help. And here on the left, you see we have this list of profiles. And these are all the different available profiles and valid strings you could pass in. So you could do -p AWS, -p CDO, -p DO. And these kind of explain the shorthand. So these are just easy convenience flags for you to easily define whichever profile you want. And of course, if you want to write your own profile, you certainly can as well. Profiles are stored in the profiles directory. Anyway, in this case, we did CAWS, which is this one here. We also could have done controller AWS Ubuntu, which would have been a few more keystrokes, so we just went ahead and did the shorthand C AWS for controller. That's what the C stands for on Amazon. Okay, so let's run our command. Kubicorn create rad demo -p CAWS. Rad demo exists. Let me nuke the state store and let's try this again. So I just did this on stage in Vancouver yesterday. Now I'm back in Seattle re-recording this for folks at home. So that's why rad demo was already there. Anyway, let's try to create this again. And poof, underbar state rad demo cluster.yaml has been created. We can cat out this YAML file and actually see what's going on here. And you'll notice that it's a very poor implementation of the cluster API. Because this is our first implementation in Kubicorn. And all we've done is we've completely abused the provider config field declaration here. And we've munged the existing Kubicorn API into provider config and effectively defined nothing else in our cluster API spec whatsoever. The goal of the project is to get this working, which it's now working. And then we can start to cherry pick directives up to the higher level master structs called cluster further downstream. And this is all hinging on what open source decides to do, and from the looks of things, it looks like we might be coming together to write a tool to do all this stuff anyway. So, exciting stuff to see where all this goes, but here you can actually see it and how it's supposed to work in the wild. Okay, so now that we've created our YAML file that declares what we want our Kubernetes cluster to look like, we can go ahead and we can apply that. So we do Kubicorn apply rad demo, and before we do that command, I have gone ahead and I have exported. There's a couple of AWS environmental variables that you want to declare before you do all this so you can authenticate with the AWS API. I am not going to share mine on the screen since we're recording right now, but there is documentation in the Kubicorn GitHub repo that explains which ones you need to export in order for this command to work. So we're going to go ahead and run our apply command, Kubicorn apply rad demo, and that's going to start to take action in Amazon. So right away, we can already see that we're doing stuff in Amazon, and we ran into an error. So right away, we started to take action in Amazon. This is actually a really great example of Kubicorn behaving atomically, basically meaning that we started to create infrastructure and mutate infrastructure. Something went wrong. In this case, it looks like the old rad demo internet gateway was already created and not deleted, which is probably a reflection of, I'm going to guess, a leftover VPC that we can go and manually delete. Anyway, Kubicorn said, oh no, I can't create this, and we're going to undo everything that we've done. So here you can see we created a security group called BB30 and some other characters, and one of the first things it did is it, sure enough, undid that creation and deleted it afterwards. So before the program exited, it actually started to go through the map, realized something went wrong, and then unwalked itself back the other way to undo whatever mutation was done. This is going to be handy because we're going to be running the Kubicorn source code as a controller moving forward. So having this sort of atomic guarantee allows us to not really care about stuff like this at the higher level construct where we're plugging it into the rest of the controller code. So anyway, let's go and delete this VPC and try this command again. So go to Google Chrome. We'll go to our instances. We don't want instances. We want to go to VPC. And I bet we're going to see, yeah, we have 3 VPCs here. So we have 2 of them called rad demo, and aha, there is our problem here. So naming clusters the same thing can sometimes get you into trouble because we actually use the rad demo string to identify a lot of the resources. This is something that you have to concern yourself with when you are doing any type of infrastructure mutation, which is how do we look this stuff up later? How do we track it? What becomes our source of truth here? Is it going to get stored in the Amazon API? Do we track it externally in a database like etcd? What does this whole process look like? In the case of Kubicorn and most of COPS, we actually just give all the resources convenient names, and we have a naming convention so that we can look them up at runtime as needed. This comes back to kind of bite us as we name resources the same name, and the program can't figure out which one it's supposed to use. So here we're deleting both of our rad demo VPCs, and we'll rerun our Kubicorn command again as soon as this is done. It's always weird when you're talking to yourself, because it's just I hope that I'm making somewhat logical sense right now. Anyway, clear our screen. Go back, looks like our VPCs are deleted, so we can pull up our terminal here, and we should be able to run our apply command again. And this time we shouldn't get any errors. It should actually go through, yeah, as expected, and start to create infrastructure for us. So again, the convention here being that anytime we mutate infrastructure, which is what we're doing right now, we want to signal that with a check mark. That lets us know that something behind the scenes has changed. And if we actually go and we look in the Amazon console, we should be able to go and see stuff happening behind the scenes. So let's go and check out EC2 and see if any instances are coming up. It doesn't look like we have any instances. Oh, we have one that's pending. So yeah, we're starting to create instances. We've created, I'm going to guess we have one of our 2 autoscale groups behind the scenes. And we can start to watch this cluster come to life. And as this cluster comes to life, it's going to take it anywhere from 5 or 10 minutes. So I might stop the video, go get a cup of coffee, come back, hit record again, and plug the 2 together. We'll see how much filler I can talk as the cluster itself is coming up. But I want to talk about this sort of concept of having a baseline cluster and why we have it and what it's used for when it does come time to actually bootstrapping a Kubernetes cluster that is then scaled with a machine controller from the cluster API. So the first thing we do is we create what we call a master node. And if you paid attention on the cluster API call today, we learned that masters and nodes are kind of this weird set of implications that sort of mean different things to different people. So I think moving away from calling a particular type of infrastructure or server or virtual machine a master is going to be something that we see more and more in the upcoming days in Kubernetes. I think instead of maybe calling it a master, maybe we call it the API server node, and we just know that this is a piece of infrastructure that's going to run the API server component. Maybe we also have an etcd node, and we know that's a very special virtual machine that runs etcd. Maybe we don't care. Maybe they're all just nodes. So in this case, following older primitives, we actually have a master. And what a master means to Kubicorn is it's going to run the Kubernetes control plane. So, I mean, this is Kubernetes 101 stuff, controller manager, scheduler, API server, etcd, all the things that sort of bring Kubernetes to life and make it work. That's going to be running on this master node here. In addition to the master node, we have one worker node. And this one worker node is a little bit special because that's going to be the node that allows us to schedule the first workload that's then going to create other nodes. So after this new node comes up, we're going to create a Kubernetes deployment and deploy our controller that will then get scheduled on this new node that has yet to come into existence here. And then that controller will then create an additional subset of nodes that then we can scale up and down just by updating a few CRDs from the command line using kubectl, which we'll do as soon as the rest of the cluster comes up. So let's refresh, see if our node is coming up yet. Aha, so they're both initializing, and I bet if we go back here, you always know that Kubicorn worked well when you see this friendly little green line at the bottom of your output here that says, yes, everything worked as expected, and you can now actually use the kubectl command line tool to interact with your Kubernetes cluster. Oop. So a quick and dirty kget no, and we should see, aha, we have a master, which is defined by a role, and we have a one worker node that we can schedule workloads to. Also, if we look here in the output, we see this snippet of code here. Now, we're only going to see this snippet of code if we run a profile that has a concept of a controller. Older Kubicorn installations and deployments did not deploy a controller, so we would have no reason to define these CRDs or to even create a deployment to run our controller in the first place. So the first thing we did is we deployed a cluster controller. And the controller itself takes about 30 to 45 seconds for the kubelet to actually pull down the image and get the thing up and running. It's a fairly big container image, in part because it vendors pretty much every library of Kubernetes source code under the sun. So even pushing this thing up to a Docker registry or a container registry takes a little bit of time. So as that's pulling down in the background, we also went ahead and we declared the name of the cluster, which this is a cluster CRD, so we can kget cluster, and that's called rad demo. We also declared our 4, 0 indexed, of course, so 0, 1, 2, and 3, totaling 4 machines that sort of look familiar to anybody who's ever looked at a stateful set before. And then we have our 2 sort of special machines here on the side, which are the ones I talked about originally, which this serves as the preliminary cluster that allows us to have some small cluster to begin to scale our other cluster with. So the way I look at it is the smallest amount of Kubernetes virtual machines you would ever have up and running in one of these deployments would be 2, a master and a node. And if you wanted to create more than that, you would just simply create a new machine CRD, and then the controller would go and reconcile that. In this case, we just started out with 4, but we're going to go ahead, we're going to delete some of these, and we're going to create some new ones, and we're actually do some auto scaling on our cluster and watch Amazon come to life behind the scenes. Cool. So if we do a kget nodes again, we can see that we're already starting to bring up our first piece of infrastructure here. And I'm going to try to kind of jump on this piece of infrastructure, a virtual machine, an EC2 instance, and show you guys what's going on behind the scenes with kubadmin. How kubadmin has a lot to do with everything that's happening here. So the first thing is we want to go to our console, we want to go to our instances, and we want to find this newly created virtual machine, or I'm sorry, EC2 instance called rad demo node 0. We're going to SSH into it while it joins the rest of the cluster. And we're going to look at the kubadmin logs and see what's going on here. So to do that, we're going to SSH Ubuntu at our public IP address. Go ahead and SSH in. We'll sudo into a new bash shell. And we'll go to our handy dandy var log directory. And we're going to cat out this file called cloud-init output .log here. So as that cats out to our screen, this is going to look real familiar to anybody who's ever ran kubadmin, which is basically you can see kubadmin going through its phases over here on the left and actually joining up and trying to connect to the API server on its local or private IP address in EC2 networking. So we were able to establish a connection with the API server here on port 443, and we were able to use a kubeadmin join token to actually join the rest of the cluster. Now, how that whole process worked was Kubicorn randomly created a kubeadmin join token at runtime when we did our Kubicorn apply. That plugged it into the Kubernetes master, and then all the nodes had a concept of this token defined, not as a secret, as it probably should be, but it was actually written to disk. And if we actually want to go, we can go to change directory to etc Kubicorn, I think is the directory. Then in here, we have this cluster.json file. And we can actually cat this cluster.json. We'll pipe it to JQ for folks at home. And we can actually see that this is a JSON representation of that YAML file we looked at earlier. And the reason we're doing JSON here is so that we can easily query directives out of it. In this case, we're going to be finding JSON within JSON, and we're going to be pulling out our kubeadmin token, which is going to be defined somewhere in this big blob below. So if we wanted to, we could do, actually, you know what, let's see if we can't do this. We could go pipe to JQ, we want to go into spec.providerconfig and see what that .spec.providerconfig, see if we can get this out of there. It's null. I wonder if spec is capitalized. Is it cluster API.spec? Nope. Anyway, I don't need to like hack on JQ right now. If you guys want to go and figure it out, you can, but it's JSON within JSON. Everything's in the provider config, and you could actually go and query your token out of it. And we can see an example of this in this directory. Let's see if I get this right on the first time. Var, I think it's var lib cloud instance scripts. Yeah. So if we cat out this part001 file here, this is the bootstrap script. That's got the etc Kubicorn cluster.json. It actually cats it here, cat eof, and it'll cat it to that file we just looked at. And then you can actually go and see all of the apt-get installs, and in here you can see this is the token command I was just talking about. This is the actual command that would pull the token out of that JSON blob we just looked at. You see that it restarts the kubelet service, and it does a kubeadmin join. So pretty straightforward stuff. The cloud provider's already been configured on the master, and this just does a kubeadmin join and becomes a node in the cluster. So there's a lot of different ways we could look at, like as a cluster API working group, at managing these secrets. Like clearly passing around a kubeadmin token and a blob of JSON within JSON is not our most viable alternative to solving this problem. But the point is we can now start to have these conversations, and we can actually see how this stuff is working. So we can start to figure out best practices and figure out how as a community we want to solve these problems. Good thing, Kubernetes is in place, and we can start to borrow these existing primitives like secrets and config maps to make this whole process a little bit easier. Okay, so enough about me ranting about what we should do, and more of me ranting about what I did the wrong way. Okay, so let's go back to our AWS console here, and you can see that we have our original two nodes, our master and our node, and 0, 1, 2, and 3 all up and running. So we jump in our terminal, we should be able to do a kget node. And poof, you can see we have nodes coming up over the past couple of minutes, one of which is 8 minutes old, another one's 8 minutes old, we have one that's 5, and we have a couple that are 4. They all come up at different times, but they are nodes in our cluster. So now let's actually look at our pods. So we can kpo in the Kubicorn namespace and see that we have a controller running as a pod. So let's get our logs. So we'll paste in the name of our pod, tell it to look in the Kubicorn namespace, and we'll go ahead and follow those logs over time so we can see what's going on here. So this is just a really simple controller. Every time you see it sort of pause, it's sleeping for a second, and then it's iterating through a loop again. And it sleeps for a second and iterates for a loop again. The second sleep is basically there for me to demonstrate that it is a loop. We don't really need it for anything. In fact, if we really wanted to crank this thing up and see how fast it could go, we could just let it loop indefinitely. But for the demo, we have it set to 1 second sleep per iteration. Right now, everything is reconciled as we told it, so it doesn't really do anything. It's basically a no-op every iteration, and we see it querying the AWS API and seeing what instances are there, and saying, okay, everything is as expected. I don't need to take any action. So here is where we really see the value of the controller. Let's go in and let's delete one of these virtual machines. Cool, it's shutting down. So if I refresh the console here, you can see the controller is already rescheduled, for lack of a better term, an EC2 instance behind the scenes. And I bet if we go back and we scroll up in our logs, you will be able to find somewhere in here, it was probably a while ago because this thing's going every second, somewhere in here is going to be the controller saying, aha, we no longer have an EC2 instance in ready state, we should go ahead and create one. I'm not going to try to look through it now, but you can see that it did in fact work. So this is pretty cool, and we could actually go through and we could take this one, our second one, our first one, and our 0, and we can terminate all of these. What's interesting is the scheduler probably has already scheduled the controller pod on one of the new nodes, meaning without draining the node, we just completely nuked the underlying infrastructure that was running the controller that was managing other infrastructure. So the beauty of having this one special unindexed node is that ensures that we always have a place to recover from a disaster like this and to begin to schedule the controller to scale our cluster moving forward. So if we run here, it looks like, okay, so the scheduler did not reschedule it. Maybe it did. Let's see. It doesn't. Okay, yeah. So the logs still are working, so we still have a socket open there. So the scheduler had not rescheduled it onto a different node. I think I might have forgot to kill it. Usually I would kill the pod and let the scheduler bring it up somewhere else. And let's go back and refresh and see. Filter on instance state. And you can see that the rad demo 0 is now running and initializing, and rad demo 1 is now running and initializing. The way that this controller works, again, is sort of modeled off stateful sets that says, like, let's create our first node, and let's not move on until that node is either ready and happy and registered with the API server, or something goes wrong and we undo it. And that's that atomic guarantee we talked about earlier, which I think is handy because you know you're not going to be able to scale up or down unless you can like get to the next step in line. So in this case, it looks like 0 went off without a hitch. 1 is coming up and running. As soon as 1 gets done, we'll see another 2, and then ultimately 3. So now let's look at some CRDs. So we'll kill our logs. We'll kget machines. And you'll see that we have this rad demo node 3. So what I can do here is I can kget machines rad demo node 3 OYAML pipe to our friend pdcopy. Echo, we'll paste that out. A lot of data here. Bear with me. Close our echo, and we'll call that new machine .yaml. Can I not do an echo? Okay, I'll just do this. New machine .yaml. Let's see if that worked. Nope, I want to edit it, so I'm going to open this up in Emacs so I can edit it. I don't know why I'm jumping around different text editors, just love you for who I am. Okay, so rad demo node 3. So let's call this rad demo node 4. Cool. And we can kapply -f new machine.yaml. Bam, kget machines. Now see that we have this new CRD declared for the past couple of seconds. And if we go back to our EC2 console here, we can probably filter on instance state is equal to running. We can see that we're on 0, 1, 2, and 3. And I bet any second now, the controller, let's actually get these controller logs again. Let's see. Nope, I broke my terminal. We can see if we can't pull it up. Kubicorn for our namespace. So we want to do klogs, Kubicorn controller, namespace, Kubicorn -f. That looks good. So yeah, you can see here we're currently working on rad demo node 4. So what's happening is we're giving rad demo node 4, which is here, it's coming up, a handful of tags. And we're not moving on to restart a reconciliation loop until after we've successfully validated that not only are the tags in place, but the actual node is up and running and has gone through a successful kubeadmin join. Imagine what would happen if we didn't ensure that. Imagine if, say, like the Kubernetes cluster tag wasn't defined. Well, for one, the cloud provider would break, so we would have some issues with the AWS cloud provider. And for two, we wouldn't be able to query that, and we would effectively have abandoned resources here. So atomic infrastructure mutations are really, really important here when writing one of these infrastructure controllers. So we have rad demo 4 up and running, and we should be able to get nodes and see that, yeah, we've had this one up for the past 40 seconds. And so we can actually edit this, where's my Emacs command, new machine.yaml again. This will be a really big one. So we'll do 5, we'll create it, we'll do our apply command again, kapply. Now we have kget machines. There should be 0, 1, 2, 3, 4, 5, so 6 nodes defined. Go to our Amazon console, refresh. Should see 5 coming up any minute here. So it looks like 4 is still initializing. So our controller still hasn't moved on to restart the reconciliation loop yet because it's still in initializing and not a ready state. So in this case, we're using the Amazon API to figure out if an instance is ready or not. And then we can do a really awesome disaster recovery scenario here. If we get the Kubicorn pod in the Kubicorn namespace, we can go ahead and delete this pod. The scheduler, by design, will reschedule this pod on a different node. So if we do git po bam namespace kubicorn wide, yeah, we can actually see that it's now coming up on this node here, 100.157. So I bet if we go and we look here, I'm looking over here on the right in this private IP space. So that's 100.12, 100.27, 100.34, 100.251, 100.157. Okay, so our controller pod was scheduled on rad demo node 4. So let's go ahead and let's delete rad demo 4. We'll delete 3.2. We'll do that. We'll say something horrible happened. There's bad weather in Amazon. An unruly software engineer came in and started to try to delete EC2 instances. There was some bad software out running somewhere. Who knows what happened? But we're going to lose the node that our controller is running on. So we'll terminate them. Already the machines are shutting down. If we get our pod here, we want to do this command. We can see that it's still trying to run it on 157. So the Kubernetes API server hasn't figured out, or it actually hasn't dropped the container yet. So some sort of eventual consistency is happening, but it's going to reschedule the pod as soon as it figures out that that node has actually gone online. So let's continue to get these pods here. And we're looking for a different pod name as we do this. Okay, so it's still running on 157. What's going on here? Are these just not shutting down yet? Let's be a little more patient on us breaking our system here. I want everything to work super fast. Okay, so if we look, we have our last couple of characters here, 9mn, whereas before we were 6cmj. So we actually have a new pod. It's in container creating, no restarts yet. The scheduler's recreated the pod. Pod's going to come up. It's going to see what's going on. It's going to fix the infrastructure. Wham kablam, cluster is fixing itself, both on the container level as well on the infrastructure level. Kubernetes to the rescue again. Deleting the cluster is actually kind of tricky because the controller is running, and we'll try to undelete the cluster as you go through it. So the best way I have found to delete one of these clusters until we can orchestrate this better in Kubicorn is to delete manually. And there's just kind of like a timing element to this, so you got to kind of get like the timing just right. You delete the node, the special node, the one that is not managed by the controller, that the controller ignores. And then once that's deleted, you delete all of the other nodes. Hopefully, if all goes well, the autoscale group won't redeploy the other node, and you'll be able to bring down all the nodes in the Kubernetes cluster, which will take the controller offline, and then you can shut down the rest of the cluster in general. So as we're doing all of that, we're going to run our Kubicorn delete command. So Kubicorn delete rad demo, and we got, like I said, we got to kind of time this thing just right. And I will select all instances in state running. And it'll do instance, why can't I terminate this? Those are already terminated. Let's see what we got here if we refresh. I don't want to miss one. Okay, so we've got 0 and 1 and 5. The controller is probably in the process of coming back to life. Oh, yep, it looks like it just created 5 here. So the controller is already kind of catching up to us, so we really need to be quick here. So instance 8, terminate. Terminate all those, jump back into command line as quickly as possible. Run our delete command, which it's now deleting, autoscale groups, launch configurations, and route tables. So clearly, a better viable solution would be to first delete the deployment that the controller is running on, and then have Kubicorn go in and delete all nodes matching certain criteria, probably going to trigger on that same key value pair Kubernetes cluster, name of our cluster, that we would for everything else. Anyway, this is how the controller works with Amazon. The source code is horrible, don't look at it. We're going to rewrite everything in open source, but you actually get to see how it works, which is exciting. And I think that's pretty much all we got. 37-minute demo. Anyway, hit me up on Slack, hit me up on Twitter. If anybody has any questions, I'm out. See you guys.